Okay, how are you everybody who is watching this video? I would like to take this opportunity to welcome you into this moment of learning the beauty of fundamental practical electronics. My name is Olenjolai, I'll be with you. And I want to tell you in advance that I don't know everything about electronics, just I know small portions of it. But I have an assignment to teach others about what I know. So in our class, I have some local students, and these contents, because I'll be using the analog teaching system where I have some students in this class, and also I'll be using the digital teaching skills where I can teach students who are not a part of this class. So whether you are a local student or you are maybe a digital student, you are warmly welcome. Be serious, concentrate, listen, ask you questions, and you have to make sure that you attend these sessions, and these sessions actually is going to change your way of thinking and your courage and your passions in electronics. So again, another thing that maybe you can be asking yourself, how can you ask the questions? For the local students, they can interrupt me to ask the questions because I love them. And for the online students, you can use, if this video will be going live, then you can use just in the chat part, or if it has already gone live and maybe you can access it in different platforms, you may ask your questions in the comment sections or in different ways that you can see, however that will be by using writing. But later on we'll be incorporating our digital way of teaching with different platforms that actually can give you a chance even to have a voice recordings of your questions, and you can send to us, and then we'll be trying our level best to make sure that we answer your questions as well as we can. So be ready for the good news that we have. So we are in online Diploma Polytechnic Institute of Tanzania, and hence this is the cooperation with Online Undergraduate Polytechnic Institute of Tanzania. This is our online schools. They are not physical institutions, they are online institutions, but we are trying our level best to apply what we have been learning in our undergraduate educations, in telecommunications. We are trying to apply and incorporate with teaching. Okay? So if you are ready, now this is the time. I would like to welcome you into the lecture or session 4. This is session 4, excuse me. This is session 4 or workshop 4. So workshop 3, I just jumped into, so I have to make it in between. So this is session 4. So it's called the Practical Electronics Engineering. Practical Electronics Workbench. So it's second chapter of this module, Practical Electronics Workbench. Very important, because in this topic I'm going to teach you where are you going to do your electronics works. Right? So that's the meanings of workbench. So this workbench will help you to do your electronics activity. Right? So we call it Practical Electronics Workbench. Practical Electronics Workbenches, or just okay, we can put in plural workbenches. So where can we do our implementations or design of our electronic circuit? That's the answer. So it means that I'm going to try my level best to answer according to the different features that are available for electronics engineer or for electronics technician. Are you ready for that?
Yes.
Yeah, wonderful. I'm happy to hear about that. So let me start with this phrase. Actually, this is to be 2.0 introduction. Let me introduce this concept to you, and then we'll dive into one of the concepts. And then let me start with this sentence, which is very important for electronics technician or engineer. Whenever we want to solve, our intention is to solve. Whenever we want to solve an electrical or electronics. So electronics real life problem. Okay, real life problem. Then the following steps, or then we often follow this algorithm. Algorithm, actually this is the terminology we use often or mostly, algorithm in computer programming or in computer architecture, in software architecture, algorithm. So I'm trying my level best to expose you about what we used to do once we think to solve the real life problems, and especially we used to term most of the real life problems in terms of project or in terms of research. So I'll be mentioning some parts that we used to follow. And then from there, you'll see that where should you start to think about which workbench I'm going to use. Are we together?
Yes.
So we can have more than 12 steps, but I've prepared the 12 steps. And I want to tell you that these steps that I'll be mentioning, for you who are in first year in engineering, you will need to follow these steps in your fourth year, junior and the senior project. In your fourth year, first semester, you have junior project, which is called the project conceptualization. And then in second semester of your fourth year, we'll have senior project. Are we together?
Yes.
And you will, actually, I'll tell you, today it is 2020, 27th February, 2020. You'll be in fourth year, 2020 plus 4, just 23 plus 4. 25. You are in academic year 22-23, first year, 23-24, second year, 24-25, third year, 25-26, fourth year. So 25, in year of 25-26, you realize what I'm teaching you today. But I remember once you'll be applying, you have forgotten what I've taught you. So the first step that we do as technicians, electronics technicians and engineers, we identify what is a real life existing problem. Because we want to solve the problem should be there first of all. But the problems can be there, but we cannot identify it, so we have to identify it first. Right? Then the second step, we have to state the problem statement. We have to state the problem statement. So we have to state the problem statement. So we have identified the problem, but we have to state the problem statement. What does it mean? So you have to write a sentence that explains briefly about the problems we have identified. Right? Simply called the problem statement. Then the third step, we have to state the main objective of the project or research. The main objective. Say main objective.
Main objective.
Main objective. So the main objective of what? Main objective of your design, of your implementation. Why do you want to design? Why do you want to solve? What are the main objectives that you want to do or you want to achieve, right? And then the next step, you have to state the specific objectives. This is specific, the combinations of all your specific objectives will achieve what? Specific objectives. Will achieve what? The main objectives. So specific objectives, these are the small tasks that you'll be doing in order to help you to achieve the main objective. Listen carefully. Specific objectives, these are the small activities. For example, the main objective is to design this. Where is your smartphone? Okay, the main objective may be to design a smartphone like this, right? That's the main objective. But in order to design a working smartphone like this one of the specific objectives, it means you can say that I have to design the input unit, right? Another specific objective I have, in order to see the output after processing whatever, I have to design the processing unit. I have to design the output unit. Those are the specific objective. So combinations of communication unity, input unity, power supply unity, output unity, processor unity, that's what make the main objective that I wanted to design an Android smartphone. I wanted to design an iOS, iPhone. Are we together?
Yes.
Yeah, so because the aim of the fundamental practical electronics is to change your mindset. Because maybe you can have a big idea that I want to do this one, but you have to break into small tasks. And these small tasks, they'll be interconnected. Once you finish this, then you can go to the next one. Because you cannot focus on the output while the input is not working. How will you know that output is going to work? But for Tanzanian students, they can start designing the output, or they'll be looking for the output in the workshop for half of the day while the input is not there. And they are happy, they are confident, and they can blame to the teacher that before you came to check us, the output was there. State the methodologies. What are the methodologies that you'll be following on your design? Methodologies are the methods. Then the sixth step that you use to state, okay, if you are doing research, you have to state the hypothesis of the research. Hypothesis, you know that we taught you the concepts of hypothesis since Form 1 in physics, in chemistry, and in biology. As one of the methods of as one of the scientific steps of solving a problem, right? Then the seventh step, but this is for research. This is for the research purpose. For the project, you don't need research. This is for the research purpose. Right? Then the seventh step, say seventh step.
Seventh step.
Now you have to draw the, but I think that before you draw the block diagrams, you used to do this step again. Okay? You have to do literature review. Say literature review.
Literature review.
Say literature review.
Literature review.
Literature review, you have to review other designs or other implementation that has been done by other technicians or other engineers concerning about a topic or concerning about a problem, because you are not the first one, you are not innovating. There are some other people or there are some other Tanzanians who have solved the same problem by maybe using another approach from the approach that you are thinking about. Or there are some Americans who have solved the same problems by using different approach that you are thinking about. So in solving real-life problems in electronics engineering, we allow you to learn from others, and especially what they have done, whether they have achieved it or they failed to achieve what they have been thinking to achieve. Are we together?
Yes, sir.
So the eighth step now, you have to draw the block what?
Diagram.
Block circuit. Okay, so this is not a circuit, a block diagram. Block diagram of your design. So you know what they mean for block diagrams and how they draw it. This is the eighth step. Okay?
Yes.
Ninth step. Once you draw the block diagrams of your design, the next step, you have to collect the data. This is in case you want to do the formal, you want to solve the problems formally. Collect the data. Then, what types of data are you going to collect? Primary data and secondary data. Primary data will give evidence that the problems exist. Secondary data will help you in your design or in your implementation. Are we together? For example, you say that myself, I want to design a system to count people who are passing in Nkrumah Street at Kariakoo. Why? Because maybe the street, the width of the street is not equivalent to the number of people who are passing there. Okay, that's your proposal. Wonderful. But you have to go there and collect the data so that you can prove the problems exist. Are we together?
Yes.
Are we together?
Yes.
The data collected should be analyzed. So to analyze to analyze the data. So actually you see that because you say that engineering is a branch of what? Science. So the 7 steps, or 7 steps that you have to follow to solve the scientific problems, we are applying in engineering. We are really applying. Okay?
Yes.
Are we together?
Yes.
Eh?
Yes.
Okay. So the 10th step now, once you have done that once, you have analyzed the data, then we ask you to draw now. So from there, you've analyzed the data, then you have to draw it, the schematic circuit diagram. This is the detail of what of the block diagram. The 12 steps now, once you draw the schematic circuit diagram, you have to implement or build the design. Then the 13 steps, you have to draw the conclusion, whether you got the result that you have been expecting or not. Okay, so these are 13 steps that we have to think formally whenever we solve whether small scale or intermediate scale or large scale real life problem. But for the matter of learning, listen, stop writing. For the matter of learning, sometimes you just identify the problem, you state the problem statement, you state the main objective of your design, then you state a specific objective for you. It means to know that once I finish this, achieve this specific objective, then I can go to the next one. Or maybe you can put a goal that in this week I have to make sure that I work on this specific objective. Next week I work on this specific objective. That's how designing is going. And that's how even implementation is going. And that's how that you can spend a short time to achieve or to have a good achievement, rather than going general. I will build one day I will build a multimeter. So I will build a multimeter. I will build a multimeter. You didn't go even to Kariako and buy a battery as your starting point of building a multimeter, because you know the multimeter needs power. So I bought a battery. That might be one specific objective. Then the next day I'm going to buy the breadboard. See here, local students, they are just watching over me. So say the methodologies, okay, you can skip this. For the matter of learning, you can skip this step. Then state the process, you can skip it. Literature review, literature review is important, even for small electronic design or implementation. You have to go through, for example, somebody in India, how did he solve this problem? So you have to learn from others, right? Yes. Yeah. Then to draw the block diagrams, this is essential now. Very important, whether for small design, for formal design, for informal design. Block diagrams is our starting point for electronics engineer to try to convey the information we are thinking about, or to translate the information that will be given by somebody else into technical part. So it's a way to present the information technically. Are we together?
Yes.
Then you can collect data, just if you're not sure that the problem is there, but if you are sure, you can skip. There's no need for you to collect data. You know the problem is there. Right? Yes. Are we together?
Yes.
Okay, you can analyze data. Okay, so because you don't have data, you didn't collect it, so nothing else to analyze. You can skip the first, the 9th step, the 10th step, you can come to the drawing of the schematic circuit. Yeah. So to teach you about the electronics workbench, I will be focusing here. Okay? In Introduction to Practical Electronics, I have taught you about this, but also I have taught you something about identifying the real life problems. I told you that you cannot learn electronics theoretically, you have to practical, right? Practical, right? Okay? Yes, I have taught you about what is problem statement a little bit, and I gave you some examples. Then the main objective, I have touched a little bit that you should have a focus on what you are doing. Then you have to split it. For example, we learn those sort of terminologies. It means those terminologies can help you to organize your work. But I talked about block diagrams, how we can split a general design or general implementations into small chunks. Right? So listen. So now let me connect with what I told you in previous chapter. You know that each block diagram always give you one specific objective. Right?
Yes.
For example, in our general block diagrams of electronics, most electronic system, how many blocks do you have? How many blocks do you have? 4 blocks. The first one? So you can say that in this month of February, because we are ending February, maybe next month of March, the whole month, regardless of how busy I am, I have exams, I have tests, I have whatever assignment, I will design the power supply for my system. That is one specific objective, and you have to make sure that you work on that. The next month, April, I will make sure that I will design the input unity of my design. That's another specific objective, and it's very important. Then the next month will be what? You are not there, I don't know the next month after April. May, right? I'll be designing what? The output unit of my design. Then now I have the output, I have the input, I have the power supply. I have to interface them with what the processing unit, because processing unit, it's the brain. Right? So I have this part, now I have to interface them. So now I can give power my circuit, and then I see if I feed the input, will I get the output? So the next month of what? The next month after May is what? June. That will be what? Designing the processing unit or control unit. Right? The next month will be what? Will be what? July. So July it will be interfacing and testing. And don't expect that the circuit will work, sir. Something expect that, but the circuit will don't work. It's good news for electronics engineers and technicians. It's not bad news. It's bad news for those who don't love this stuff. But for those who love it, it's good news. Because that's how electronicity is. It can work today, tomorrow it can reject its work. You should be happy. That's how electronicity is. It can reject work today, then tomorrow you test it, it works. But you have to make sure that you make it in such a way that it works continuously. And that's what will make you distinction. Because if you make it and it works today, tomorrow it works easily, everyone can be an electronics engineer or electronics technician. So that kind of the failure for the system to work, or to work today, tomorrow it doesn't work, it's good. Because they isolate for those who have been just following the group and following the mob psychology. Then they say, no, these are the crazy stuff. They are working yesterday and then today it's not working and they didn't touch anything. Let me run away from them. Then you say, okay, thank you very much. Congratulations. Don't worry, this is not your way. Are we together?
Yes.
Okay. Now you are saying yes because you know that I'm talking about other people. But I'm not talking about other people, I'm talking about you. And I'm talking about me. Because this is not a challenge only for you, even for myself. And you know that one thing which I thank from God, whenever I teach, I used to teach also myself. I want to tell you that this is workshop 4. We started workshop 0, 1, 2, 3. God has been teaching me a lot of new concepts when I've been teaching you. For you, you don't know. You thought that maybe I had in preparation. But in most cases, I used to teach 50% of what I prepared. So the other 50% is just coming here. And also even myself, I'm receiving. And once I finish, I go and write down because it was something I didn't know. Wonderful. The teacher who is teaching others, then teaching himself. It's time to hear about that. Most of them, they came and teach others. For themselves, they know it.
Yes.
So then to draw the schematic diagram, then to implement or build the design. So it means that in chapter 2, we'll be focused on drawing the schematic diagram. That is for the software. And then the next part, in the same chapter, then how you can implement or build the design, but we'll be talking about the workbenches that can help you to implement or design the circuit in hardware. And this can help you to draw or to implement or build the schematic circuit or the circuit in terms of the software. Are we together?
Yes.
I will be teaching you about where should you work at the focus of chapter 2. Not how can you build now. Are we together?
Yes.
Are we together?
Yes, sir.
Okay, good. So if that's the case now, let us go. Let us now focus to the first part. So you say the schematic. If you have any question, don't hesitate to ask it. The schematic circuit diagram. The schematic circuit diagram. The schematic circuit diagram of the design or implementation. Okay? The schematic circuit diagrams of the electronic circuit, of the electronic circuit, of the electronics, of the electronic circuits can be drawn. The schematic now can be drawn either on paper. We draw circuits on paper by using what? Side, by using what? Yes? Pencils. Ruler. Another? Rubber. And what? And the other drawing instruments or equipment? The other drawing